Okay, so in this video for part two, I guess we're going to call it, we're going to talk about the somewhat more modern aspects of the space program. So as a recap, we ended talking about Apollo. So remember in Apollo, we had that really, really cool looking Saturn V rocket. Obviously, we went to the moon, very fancy. Um, Here is a pretty cool picture. So this is Armstrong from Apollo 11. This is him leaving for the launch pad. It's pretty cool. And then after we landed, they came out with all these, pretty cool commemorative things. Hey, this is what we did. Got some cool photos in here from the lunar mission. And then here's a good view of the lander. Yeah. Okay, so after that, again, it's kind of wild to me. Like there were plans for more Apollo missions, but literally people got kind of bored with it, and like the Congress was like, "Yeah, we don't really want to pay for this anymore." So, stop. But in the space industry, it's kind of a thought process of waste not, want not. So things get reused and repurposed pretty frequently because, spoiler, rockets are expensive. Um, and of course, now the next big thing everybody was thinking about was, okay, how do we stay in space for longer durations? Like you need something called a space station. So we're not the only ones to have this thought. Guess what? The Soviets had the same thought too. So the Soviets built the Mir space station, and it was in operation until 2001. Excuse me. And it was built in low Earth orbit, so where it was hanging out between 86 and 96. So um, it's not a bad time frame to build an entire space station. And it was owned and operated by the Soviet Union. And of course, during that time frame, the Soviet Union ceased to be and Russia came to be. So that's why I had to put that it's also was also slash owned by the Russian Federation because it did change hands because the country changed hands. Um, at the time, it was the largest artificial satellite in orbit. That has obviously been surpassed. And of course, it had about an average crew size of three to keep that thing running. Mostly Soviet Union cosmonauts slash Russian cosmonauts, but they did sometimes let American astronauts on board. So in space, one of the great things I love about space is countries do kind of put aside their personal differences, especially, this is after the Cold War and things like that. Um, Even to this day, like there's definitely still some tensions between Russia and the United States. But when you go up to the International Space Station, more on that later, they get along. Like they understand, like space is such a high risk, dangerous situation to be in. You can't let your guard down. You can't let petty differences get between you because then you could all die. So I like how space kind of unites people, basically. Then we had the Skylab space station. This was the American space station. It also had about an average of three for crews, and it was in operation for only about a year and a half, so between 73 and 74, so not very long. But we did do a lot of cool medical experiments. We took some really good solar observations and other kind of science experiments up there because it was a fundamentally a science space station. And what was great about it is, again, waste not, want not. We used Apollo rockets and equipment and things like that to get more life out of them because we spent all this money on the Apollo missions and then they kind of abruptly ended. What are we going to do? Ironically enough, they didn't maintain this super well. It probably could have been a lot better in terms of how they handled it, but they didn't maintain it. So eventually the orbit decayed and it fell back to Earth, and a lot of it burned up in the atmosphere. Not all of it. They actually found pieces of it scattered across Australia, and Australia was not happy with us. They sent us a bill to clean up. Um, I remember seeing a piece of this thing at this Marshall Center in at Huntsville when I was at space camp, and I just remember thinking that looks like a big bale of hay or straw. Like that was the part of it. I can't remember what part it was because at the time I didn't even think to write that down or anything because I was like 14. But I remember thinking I was like that looks not very fancy. He looks like a pail of hay. I can't speak today, but you know what I mean. So. All right, here comes the space shuttle program. This is the one that a lot of people recognize, maybe from my earrings. But this was one of our longest running parts of the space program, and frankly, very successful. So it ran from 81 to 2011. I remember when this thing, when it, the final mission stuff happened, because by that point I was in college and I was very sad because my whole life going to all those different space camps and programs, I had been training and thinking about how to fly a space shuttle and how to operate a space shuttle because I want to be a mission specialist. And they're like, and it's done. I was like, but what? Like, either way, I get why they did it, but also I don't get why they did it. Part of why this program was so successful and why we had so many missions, 135. So if you ever see a patch or anything that says STS, Space Transport System, that's a space shuttle mission. And we had 135 of them, which meant 852 astronauts flew aboard this thing. And part of why it's so successful is because they were reusable. Got my models. Okay. They were reusable. That's critical to saving money. So by the time the space shuttle program rolls around, they have kind of started to figure out, oh, we can't only accept white male pilots. We should probably expand the criteria. Because this is again after the civil rights movement. This is we've had some major women's movements, things like that. So like people are wanting more access, and there's plenty of highly qualified people of color and women who should be allowed to apply. So this is the first group of shuttle astronauts that were picked. This was the first time women could apply, people of color, and civilians, meaning you did not have to be military anymore. Because even prior to this, you still had to be military. So that was huge. Now, just because you are, fit any one of the criteria doesn't mean you were automatically accepted. It's still a highly competitive process. Um, but back in those days, they selected larger astronaut groups because they were flying 7 people at a time. So the crews had a commander, a pilot, and then mission specialists. So you could have 7 people because there was room. So this is their little cockpit up here, and this is where they'd hang out. And it's actually kind of like 2 story, so they could hang out in here. We got a payload bay that could hold entire satellites and things like that. This is how we assembled the International Space Station, is we took up pieces of it at a time in the payload bay of the shuttle. They did EVAs, they assembled it. It was great. So there's a shuttle fleet because we had a rotation of these things. We launched these so frequently, we had a rotation, and it's crazy. So we had a rotation between Enterprise, Columbia, Challenger, Discovery, Atlantis, and Endeavour. Endeavour is the one that's on display at the California Science Center, although right now it's covered up because they're building a whole new museum like around it. But I got to kind of see it last time I was there. It was still kind of covered up, but it's pretty cool. Columbia and Challenger, we'll talk about that. Um, and Enterprise, that name may sound familiar if you're a Star Trek fan. That's where they got it. Okay, so let's talk about some notable space shuttle program astronauts. Because again, we have a better selection pool. We have different criteria for selecting people. So we're going to get some very diverse backgrounds, which is what you want in your astronaut pool. You don't want just all white male military pilots. That was rude. Um, so first up is Sally Ride. She was the first American woman to make it into space. She was not the first woman in general to make it into space. That was Valentina Tereshkova of the Soviet Union. Not too long after Gagarin went up there, they were like, "Oh, let's see if women can survive." And so the Soviets sent a woman up way before us. I should put that in these slides. Anywho, so she was launched on STS-7, which was a Challenger mission, and she launched on June 18th of 83. So she was considered a mission specialist. So the mission specialists were the ones who basically did a lot of the EVAs and scientific investigations and things like that. Now, don't get me wrong, everybody did something during a mission, regardless of what point of the mission it was. But like when it's like time to fly this thing, you want the pilot and commander in charge, obviously. But when it's time for science experiments, so they would pick scientists for these roles based on what their science specialty was, whether it was biology, geology, whatever, engineering. And so that because they had a specific scientific mission in mind for them. So in the case of Sally Ride, she was trained with a master's and a PhD in physics. So she was actually Dr. Sally Ride, excuse me. Got it, give respect on the name. Then we have our first African American to reach space. His name is Guion Stewart Bluford Jr. He reached the rank of colonel in the U.S. Air Force, and he was a fighter pilot before becoming a mission specialist for NASA. He launched on the mission right after Sally Rides, also on Challenger. Yes, Challenger. And see, he was August of 80, so she was 2 months ahead of him. So within 2 months, he launched. You can see here, this is him later on in his career. This is like when he was probably first picked. And here he is on a shuttle mission using, it looks like an exercise equipment of some kind. They have like different exercise equipments. And what's fun about space is because, microgravity, things float. You have to like tie yourself down to the exercise equipment and to the toilet. And you have to tie yourself to the wall to sleep. And yeah. Next up, we have our first African American woman in space, Dr. Mae Jemison. And so when I say doctor for her, I don't mean PhD, I mean MD, as in medical doctor, as in she went to med school. And I've actually been in the same room as her. I couldn't quite get to meet her. She was at an ACES conference that I went to in college, and she was like the keynote speaker. And I tried so hard to get too close. I wanted to meet her. So close. But maybe one day. But what's really cool about her, so again, she was trained as a mission specialist. She flew on the Endeavor in 92. And she has degrees, not only her medical degree, but she also has degrees in African American studies and chemical engineering. So she's just like this well-rounded, awesome person. And what's super cool, it's kind of a full circle moment here. So if you notice, there's a Star Trek uniform on your screen. She grew up watching Star Trek. And if you know anything about Star Trek, you know of how progressive of a show it was for its time. It featured in prominent roles women and people of color. Things that we didn't do in other shows in that time frame, in the 60s and 70s especially. So she grew up watching Star Trek, specifically Lieutenant Uhura, the black woman on Star Trek, if you don't know. And she wanted to be just like her. And it's kind of this crazy full circle moment because there's a reason Mae Jemison is wearing a Star Trek uniform in that picture. It's because after she got picked to be an astronaut, they found out about her love of Star Trek because Star Trek is still very much a thing to this day. And they put her on a show as a character. How cool! She literally got to live her dream in more than one way. You can see this is her on the shuttle there, um, you know, kind of posing, doing science things, floating in microgravity, as all the cool people do. Then we have the first Native American to go to space. I feel like my photo being over almost perfectly, just kind of crouched down a little bit. See, look, it fits. It's kind of serendipitous and like maybe foreshadowing. But so this is John Harrington, Dr. John Harrington. I've actually met him actually at an ACES conference. I definitely tracked him down because he's actually from Oklahoma. And so not only is he Native American, he is Chickasaw. He's a member of that nation, and he actually got a tribal flag, as you can see in this photo here. I believe that was their governor. I don't remember their leader of their tribe. It's called, I think it's a governor. Some tribes are chair people, some are, anywho. But he got a tribal flag and he took it with him to space. So that's pretty cool. He launched in 2002 after being selected in 1996. So he has a background as a U.S. Naval aviator, along with a degree in math, a master's degree in aerospace engineering, and a PhD in education, which he got after his space career, I do believe. But either way, he had the smarts to, that's why he got picked. And he's actually a pretty cool dude. He loves to like bicycle and things like that. That's his, I think it's how he relaxes and stuff. He rides bikes long distances. He's a pretty cool dude. I met him at an ACES conference. I look really derpy in my picture, but I don't care because I got to meet an astronaut and a Native American astronaut at that. Okay, and then so Shannon Lucid is also notable to me. That's why I included it in her in these slides. So when she was selected as a part of astronaut group 8, that was the first group of astronauts that allowed women and the minorities to apply. So the start of the space shuttle program, basically. And of that group, she was one of 8 women. Not only was she part of that group of 8 women, she was also the only mother to be selected. Like she already had kids. That was kind of a new thing. And the reason I bring her up, because yes, it's notable that she got picked as she was a mother and all that good stuff. No, she wasn't the first woman in space. We already talked about Sally Ride. But I bring her up because one, she's from Oklahoma. Technically, she was born in Shanghai, but her parents were missionaries, but the family's actually from Bethany. So, which is like right down the road from me. So, I grew up my whole life driving through Bethany and seeing signs like home of Shannon Lucid. Um, so she was again a mission specialist, and she spent at the time like a record-breaking amount of time in space altogether. So she was even one of the rare American astronauts who got a stay on the Russian space station Mir. That's pretty cool. Um, she is a very well-trained pilot, or she was, I should say. I don't believe she's with us anymore. She had a bachelor's in chemistry, a master's in biochem, and a PhD in biochem, all of which came from Oklahoma University. And I will try not to let my feelings on OU versus OU get in the way. But either who, another really cool astronaut from Oklahoma, and she did some really notable things. Here's a kind of a small list of Oklahoma associated astronauts. So the Oklahoma Historical Society website lists all these different people associated with the space program from Oklahoma, some of which are people who were like born here or like have their roots from here, like Shannon Lucid being from Bethany originally, even though she was born in Shanghai. But some of them are associated with Oklahoma because of their training. So, like Wally Funk, who became the oldest person to go to space a few years ago, she was trained with the Flying Aggies at OSU. She was actually part of this group called the Mercury 13, which was where NASA basically picked these women who had like very similar backgrounds and athletic abilities to the Mercury 7 and just wanted to see if they could handle the same training and everything like that. But then they didn't let them fly, which is kind of like a jerk move. Um, so she never got to fly until Jeff Bezos stepped in and was like, "Okay, you can fly with me on my rocket." And she got to cross the Kármán line. She officially became an astronaut, and she also became the oldest one. So we've got Thomas Stafford. He's a really notable one from Oklahoma. He actually has an aerospace museum out there in his hometown. Um, I got to see him speak at his museum a couple years ago. He seems like a really cool dude. Let's see, we've got some people. I got Garrett from Enid. We've got Cooper from Shawnee. Hayes, I've met Fred Hayes a couple years ago at the Science Museum. He's actually an OU graduate. He's not like born here, but he's an OU graduate, so that's why they consider him an Oklahoma astronaut. Okay, let's talk about the space shuttle and all the different parts on it. So, space shuttles. They launched from Kennedy Space Center in Florida. Mission control, within later, at a certain point, once you reach a certain altitude, mission control goes from Kennedy to Houston, which is the Johnson Space Center, and that's who runs the rest of the mission. When they came in to land, unlike prior space programs, it was capsules and they landed in the ocean. This thing, this orbiter, lands like a dadgum plane. Notice the wheels on the bottom. That's not just because it's fun to go wee on my table. That's because this literally landed like a plane. It had landing gear. So when it came time, obviously, when you're coming in that fast, you need to have a very long, long, long landing strip. So what they would do is they actually landed at this place called Edwards Air Force Base out in California. It's out in the desert. There's nothing else around. They're like, you know what? You have nothing to hit. So this is the orbiter. You'll notice it's got black tiles, white tiles, and some gray tiles. Um, these are supposed to be black on the bottom, but they're not. Anyway, is this one better? This one's better. There we go. Shame. So basically this is based on heat absorption. So the black tiles absorb the most heat. The white tiles absorb the least amount of heat. What's really cool about these shuttle tiles, if you get to see one in person, you can literally have somebody holding a blowtorch to one side and you have your hand on the other side and you won't even feel it. Because these things are so good at deflecting heat away. It's really crazy. So you've got the crew quarters and the cockpit and everything up here. Again, it's kind of a two-story thing up here. There's like a ladder to go up and down. But again, it's kind of like a cockpit, kind of like a plane. And then you got the payload bay back here. You've got these small engines at the back, which we will hear about again soon. And when this thing orbited, it orbited at 17,500 miles per hour. That's a heck of a speeding ticket. Now, off to the side on the launch pad, we've got these characters here. These are called solid rocket boosters. And as the name would imply, the fuel inside of them is of the solid variety. It's actually, as I found out later through grad school, it's actually in a 16-point star because you need both of these to burn exactly the same at the exact same point in time. Because if even one of them is off slightly, your rocket's going to go the wrong way. That's a problem. So these guys provided the initial liftoff thrust to get away from the ground. Okay, so we're talking about 3.3 million pounds of thrust each. They would eventually, once you reach a certain altitude, fall off, and you're left with the orange guy and the shuttle. Just keep it on going. Okay, so these fall off. They land in the ocean. They go get retrieved. They get repaired. They get reused. Then we have the external tank. That's this big orange dude. This is the big mama in terms of fuel. Okay, so in rocket fuel, hydrogen is the one that everybody likes because it's very, very good at its job because of how flammable it is. And we tend to keep it in the liquid state. Well, the problem is hydrogen does not like to stay in the liquid state. It's naturally a gas. So it's constantly trying to essentially boil or phase change back into a vapor. But the external tank here, that's what held our liquid oxygen and liquid hydrogen fuel. Very, very combustible. This part, it broke apart after separation, and we just get like pieces back. We did not keep those so every shuttle mission got a brand new ET. So here's some examples of the shuttle components. So here's our solid rocket boosters. So here's an interesting fact. So it landed out in California like a plane, but then we launched from Florida, which notoriously is not next door to California. So to get it there, NASA made a very, very large plane, but it literally just like made the shuttle ride piggyback and flew it across the country. And to prevent excess drag from pulling this thing out of the sky, as you can see, we cover up the engines, so everything's more streamlined. So for aerodynamics, you don't have this just tragedy happen where it falls out of the sky, because like rough edges and things like that, like you would see on these engines, those are going to cause drag, which is going to pull you down. This right here, it's on, so you can see it's kind of a road. This is Florida. You can see, so Kennedy is right in the middle of like the Everglades and swamp. Like there's critters all over Kennedy, and they have caused some problems with shuttle launches in the past. But you can see this thing is called the crawler. It is going a whopping like half a mile an hour, maybe a full mile an hour. Like people can pass this thing walking. But that's how we very, very slowly inch it to the launch pad. Okay, and unfortunately, we have to talk about some more sad stuff. So most shuttle missions went great. Nothing to write home about, nothing to be of concern. Again, that's the biggest thing is when you have so many successes behind you, sometimes you get complacent. And I don't want to say that happened in these cases, but there were concerns raised, especially with Challenger at first. People knew the unseasonably cold weather was going to cause a problem for the O-rings on the SRBs. Basically, the O-rings, think of them as like they're kind of like rubbery, and rubber and cold don't mesh well, which means it's going to impact its functioning. And so there were people who knew this, and they tried to relay it up the chain of command, and people ignored them and said, it's fine, it's fine, it's fine. It wasn't fine. So for Challenger, that happened on January 28th, 1986. As a reminder, Apollo 1 was January 27th. Just not in 86, obviously, it was 67. But what happened here is this was the shuttle that broke apart during launch. So 73 seconds after launch, to be exact. This is the one that a lot of people, including millions of children, watched live because NASA had just started this brand new teacher in space program where they selected highly qualified teachers to get training as an astronaut And then they were going to launch on the shuttle and go up into space and do lessons for their kids from space. Great idea. Sounds awesome. The first teacher to get flown into space was on this shuttle. There was no more teacher in space program after this. You can't come back from that. So her name was Christy McAuliffe. And this is actually from later on. And so this is from 96. So this is like the 10-year talking about her legacy and things like that. And Krista was so beloved by so many people, as were all these astronauts. A lot of them were seasoned astronauts. This was not their first thing. And it caused such a controversy and such a backlash because kids watched this on TV live. It did not go well. So NASA immediately halted all launches, tried to figure out what went wrong and why, and how do we never do this again. As we always do, we learn. That's the only good thing I can say about these tragedies is we learn. And it's recently started to come to light. So the initial thought was because basically that hydrogen, remember that volatile substance? So if it has to be kept at so cold of a temperature to keep it in the liquid form, everything else interacting with it also has to be kept at that super cold temperature. And if anything even warms up a little bit, then you're going to have this explosion situation happen. And hydrogen explosions are notoriously just ridiculous. Like they're extremely combustible. And so what had happened was that the fuel tank exploded. And initially people thought those astronauts died in the explosion. They weren't exactly looking for bodies initially, but they found them because that the crew cabin, the cockpit, it is mostly, I think, titanium, is very sturdy, and it actually survived the explosion. And we know it survived the explosion because when they found them on the bottom of the ocean floor, it was clear that at least two of them were cognitively aware of what was going on and had activated their emergency oxygen packs. That's their training kicked in. Because I am not going to lie to you and say that astronauts are not trained for this. They are trained to expect the worst in some cases, so they train for the worst situation and hope it never happens. Well, these at least two crew packs were activated, meaning they survived the explosion and they knew what was going on. More than likely, because they found them in the crew cabin at the bottom of the floor of the ocean, they died upon impact with the ocean, not the explosion. And we didn't find this out till, I don't remember what year, but not right away. NASA didn't want to release this right away at the time because, that's a lot of news for a family member to take. And they were trying to keep that on the down low. But I think the media kind of forced their hand. Stupid media. So if you look at the mission patch, you can see the little apple for Krista next to her name. And then we get to the one that really hurts for me anyway, because I remember this one. It's the Columbia. So again, I grew up going to space camp, wanting to be an astronaut. I still do. I knew the ins and outs of these space shuttles. I knew the ins and outs of how these launches worked. I watched them all the time. I went to Kennedy when I was 7. Didn't get to see a launch, but it's okay. So with the Columbia, it launched in 2003 in January. During launch, a piece of foam from the external tank, that orange thing, it broke off and it struck the wing of the orbiter. And remember those heat tiles all the way around, they're there to prevent heat from getting inside. And if you have a divot or a chip or anything that's out of shape, heat can now get inside. Heat expands rapidly. And that's basically what happened. So their mission was great. They was success. They did all their experiments. They had a great time. There's even the first Israeli astronaut on board, so another notable character. And as they were coming in for a landing, that heat shield in that particular area where the foam piece had struck it essentially failed, and it was just like a domino effect. So this shuttle broke up on reentry, not launch. So they had their whole mission, they did great, and they broke up on reentry. Um, and I also saw that one on TV. So this was 2003, so I was 12. And this is the Daily Oklahoman. I had just had that top folded down from obviously this tragedy that I bought with my own pocket money because I knew at the time I was like, I have to get the paper. Like, I guess that's how I was processing my grief at the time. I was like, I have to get the paper. Like, I have to. And I'm glad I did. I'm glad I saved this. Later on, I would buy like the commemorative, sorry, Shadow, little magazine about them and all the crew and all their cool things they did. Obviously, NASA did not take this well. They lost another crew of 7 astronauts, and it like again, launches got put on hold for a very long time, and then we lose the entire shuttle program in 2011. So it was a heck of a thing to come back from. And nowadays, the reason when you see a launch and there's so many different angles around the spacecraft, all those different camera views, is because of Columbia. Because they need to have eyes on every single part that is critical or even possibly critical. Because, like I said, Kennedy is basically in the middle of a wildlife area. Like they've got woodpeckers, they've got alligators, they've got all sorts of critters. And sometimes those critters do damage parts of the mission. Um, so they need to be aware of that so they can fix it before something like this happens again. So, can't talk about space history without talking about the International Space Station. So, hence the name, it is international. It is not just our space station, it's not just Russia's space station, it is everybody's. So, like the Japanese contributed a really cool science lab. The European Space Agency has made a ton of parts for it as well, with all their different countries that are organized under them. So, it is the largest man-made structure in space. Again, it was a cooperative effort between all these different agencies. So, NASA, ESA or ESA, the CSA, JAXA, and Roscosmos. It was assembled in space again via the shuttle. It goes around the Earth every 90 minutes. There are plenty of really cool websites out there. You can track it and see exactly where it is. When it's flying overhead, you can actually kind of see it. It looks like a little fast-moving light. It's been continuously inhabited, I can't speak today, since November of 2000. So that is over 25 years of continuous presence of people on this man-made space structure. That's pretty cool. Since then, at least 270 astronauts have visited or lived there for varying amounts of times. What's cool about the space station is not only is it a great place for all kinds of different scientific studies to happen, but also it is designed for long duration stays. It is not designed to be up there for a week and come back. It is literally there for people to be there for a year or so. And that's actually happened in more recent memory. People have stayed there for close to a year. Um, both planned and not planned, because they were trying to figure out what's going to happen to their body when they're up there that long. Because looking toward the future, going to the moon for longer periods of time, going to Mars, those are very long times we're going to spend in space. We need to know exactly what's going to happen to the body. How do we recover from it? Why does it happen? Things like that. Let's see. There are two main languages spoken on board, English and Russian. So yes, our astronauts learn Russian because you got to be able to talk to your crewmates, and they learn English. Um, that's one of the things they learn once you get picked for astronaut candidacy is you learn Russian, in addition to survival skills and everything else. Currently, we have Expedition 74 on board. They'll be there through the summer, and then we'll move on to Expedition 75. So here's some cool facts about each part and what country made what. Currently, for space endeavors, so for a while there, to get to and from the space station, we were having to hitch rides with the Russians, which that cost a lot of money. It was like well over $1 million a seat for each American astronaut, and they could only launch one person at a time because Roscosmos capsule was like three, it seats three. Um, so yeah, they couldn't launch a whole lot. So that's when we started looking toward private companies like Boeing and SpaceX. They're starting to work on different capsules and suborbital rockets and things like that because they realize working with NASA, there's a lot to be gained here, and NASA gains a lot from them too. So by having these companies on board to produce these capsules and things like that, we can still continue to select and train astronauts, and then we can get them to and from the space station much easier. And it's still cheaper, even though we're paying a private company, it's still cheaper to pay them than get an astronaut to Russia, launch them. Actually, it's from Kazakhstan, but and then get them up that way. It's still cheaper. And nowadays, we're also getting to something where there's these commercial astronauts. So basically, um, if you see people who fly on like the Boeing Starliner or the SpaceX Dragon capsules and things like that, they do the little quick like whoop bloop flights, the little suborbital flights. After they pay a gigantic sum of money to do that, those are called commercial astronauts. Um, my personal feelings on the matter. I don't think they should be called astronauts because to me, an astronaut is someone who is selectively trained and picked for their skill set by a government agency, a government space agency, not who has the largest purse. So I think there needs to be, especially moving forward in the future, there needs to be different categories. Just because you cross the Kármán line doesn't mean you should be considered the same as someone who spent a year on the International Space Station or walked on the moon. Those are two very different things. And there is some discourse happening to that measure because I'm not the only one who feels like that. All right, let's talk about Artemis. Okay, so Artemis is our current space program. Very exciting. Long overdue, but super awesome. So, again, we've had this goal of going back to the moon since the Apollo mission. Is it a bit longer than drawn out than it should have been? Probably. But, again, safety is everything. Having the right technology is everything. So our goal here is not only to go back to the moon this time and be like, yay, we did it, gold star for us. We actually want to set up a permanent presence there. We want to set up an equivalent of like a way station or a midway point that we can use for missions to Mars in the distant future. Because Mars is really freaking far away. Okay? Don't get me wrong, the moon is too. We know this. But having kind of a halfway point where we can get resources like that possible frozen water in those craters or different our H3, things like that that we can use to our advantage is going to be so much better than trying to take everything with us. So the Artemis program currently is slated for 5 missions through the end of 2028. And again, it's a jumping point or to get into the future of Mars missions, hopefully. And to make this possible, NASA has been working with space agencies and private space companies around the world to create the next lunar rocket, which is called the Space Launch System. It's this guy here. It's also back there. So, so here's kind of an overview of the timeline and goals for each different Artemis mission. So Artemis 1, just like has been established before, uncrewed, no people, just a test of the rocket because again, it was brand new. Didn't know what could go right or wrong. So there was no crew. It was just purely a test of the rocket itself and the Orion capsule. And this mission was actually 25 days long while it went around the moon and back. So we could do different tests with it, find out what was, how it was, what was it thinking? What was it taking like? Then we had Artemis 2. That was the most recent one of April of this year. It's spoiler, it's still April, so it's still very fresh in my mind. It's still very exciting. Um, so here's the pretty launch. Yay! Now, this one was exciting, not only because we're finally going back to the moon, finally, but also because we launched the first woman and person of color from as the farthest distance from Earth anyone either of those categories they've ever been for. And this was a 10-day mission. It was a flyby mission, not a landing mission, but we did get some really cool data and everything from it. More on that in a minute. Next up is going to be Artemis 3. That's slated for about halfway through 2027. Even just a couple hours ago, I was looking on NASA social media. They've already started to roll out the core phase of that rocket from where it's being built in Louisiana and start getting it ready to head to Kennedy. So, like, it's already in the works. The reason for Artemis 3, so it's not going to be around the moon, but it is critical, kind of like how Gemini was critical to the Apollo mission being successful. It's going to be critical because, again, we need to test the future lander, practice rendezvous docking, all of that. But we're going to do that close to home in case something goes wrong. So that's, again, there's going to be a crew, but we're going to be doing that probably in high Earth orbit or low Earth orbit. I don't remember which one. But the whole point here is to make sure that private spaceflight lander, either whether it's Boeing or Blue Origin, whoever it is, make sure it works with Orion. If it doesn't work with Orion, we got a big problem on our hands. Then we have Artemis 4. That's going to be slated for early 2028. This is the big one, the big kahuna. This is the one where we are actually going to have boots back on the moon. Yay! So that is going to happen early 2028. Neither crew for 3 or 4 has been announced yet, as far as I know. I've been looking. Um, I'm sure there's a lot of really awesome people who would do great at both of those missions. My thoughts are for Artemis 3 especially, they're going to want some really, really good pilots because it takes some finesse to dock spacecraft. And then lastly, we have Artemis 5. Again, this is what the budget is currently set out for currently. Things can change because, again, NASA is funded by Congress. And this is going to happen late 2028, so this will be another crewed landing on the moon, but this time we're going to work on setting up our permanent base there. So we have more of a reason to keep coming back at least once a year or so after that. Okay, so Artemis 1, here's some pictures from Artemis 1. Again, this was the uncrewed test of everything flight. So this is day 6 from the mission. This is from day 11. You can see Earth in the far distance there. This one is day 20. So this is when we're starting to return and head home. So the moon's in the distance behind us. So this is over here. This is on approach. Over here, moon's in the background. And then this is day 26 for splashdown. So again, it's not in this picture, but they will erect a flotation stability ring around it. And then we also have these balloons inflate for stability so it doesn't like tip over and things like that. Because when there's a crew in here, you don't want it just tipping over. Here's a flight path for Artemis 1. You can check that out. Okay, Artemis 2. So, first crewed lunar mission in over 50 years. Again, it was a flyby, not a landing. This is their little mission patch here. And it was pretty cool because the ones they wore in Mission Control and things like that, you could actually turn them over to show, what was in the background, whether it was heading to the moon like this one is showing, because Earth is in behind you. And then when they were headed home, they flipped it over, so now the moon is in the background, and we're heading home to Earth. It's pretty cool. So this one launched April 1st, 2026, and they came back on April 10th. They landed as a splashdown off the coast of California. Yet again, the Navy played a critical role here and came and got them. And their whole mission was about just over 9 days. So if you watch any of the live feeds or the recordings or anything like that, you'll notice they keep saying the word integrity. So the Orion capsule itself, that's the name of the structure. Just like with the Mercury, we saw they had Liberty Bell 7 and things like that. So the integrity is what the crew named their actual capsule. So it's still an Orion capsule, but it's named integrity. So this mission is also historic, not only because we went back to the moon for the first time, but we also selected a highly decorated astronaut crew, and that included the first woman, the first person of color, and the first non-American to reach the moon. This is huge. It's showing where NASA's goals are, what they're aligned with, what their plans are for the future. They picked a heck of a crew. Victor Glover was the pilot, and he is a dang good one. So this crew was extensively trained beforehand. So even though they didn't land on the moon, it was still a scientific mission. They were trained in specific skills related to like photography and lunar geography, how to collect and properly like annotate what they're seeing, because the moon is not just gray and black and white. It actually has colors which you can see with the human eye that cameras really can't do justice. If you look at it through a spectrograph, you can actually see those colors, but basically it's got all these different minerals and stuff on the surface, and they actually make it look kind of bluish. There's some pinkish colors, there's orangish. It's all because of those different minerals, and they were trained on how to best relate those findings and what they're observing with their own eyes back to mission control. They had a special science room for this mission. Never before has this happened. They had a special extra room on Mission Control was just a room of scientists taking in all this data, taking in everything they sent to them. It was just amazing. They also flew these little chips down here. So just think of it, they called them like avatars. Not Avatar the Last Airbender. But that was a way to make like an organ on a chips because again, we want to know what's going to happen to the body when you're really, really far from Earth for a really long time. Because when you're still in um, orbit around Earth, like on the space station, you still kind of get some of the protective benefits of Earth with the from radiation and things like that. You still there's still radiation you're exposed to, but the Earth still is kind of there like a big brother protecting you. Once you go to the moon and or Mars, you're on your own. So we need to know what's going to happen to our human physiology when we're that far away and exposed to higher levels of radiation, longer periods away in, microgravity, things like that. So we just need to know all these things. So they put these little avatars with them, and they're super cute, and I can't wait to see what they find from those. So here's kind of some quick bios and things over the crew. So the commander was Reed Wiseman, the pilot was Victor Glover. Then we had Christina Cook and Jeremy Hansen. He was the Canadian astronaut on board. My nose itches. Oh my God, I just realized he has my birthday. We're twins. And she's almost by my birthday too. We should have a birthday party. Okay, I should stop now. I need to go to sleep. They, again, very famous, very awesome people. They made the cover of Time magazine. Here's some amazing shots of launch day. You can get so all these images of the mission are from NASA's website. Like all the images are free and you can download whatever size you want. It's super cool. So you can see different angles of launch and you can see the SRB separation in this photo. Here are some pictures from see what day was it? This was Journey to the Moon. So you can kind of see, here's Christina Cook. I believe she posted the same photo on her Instagram as well. You can see the moon there. You can see this is a really beautiful picture of Earth. We're getting closer to the moon, so you can see more details. And then this is more from the lunar flyby. So this is when they're actually that's on close approach, as close as they were going to get to the moon, taking all these detailed images, reporting their findings, etc. At one point during the lunar flyby, we had a total eclipse. And so, of course, as always, they wore their safety glasses. You have to wear eclipse glasses. Never look at the sun. I feel like I have to tell you all that every week. Don't look at the sun. And you can see this is an image of them taking their photos. You can kind of see like the tablet up ahead, kind of helping them. Like I think it had like geology maps and everything up ahead. But again, they had already trained this and learned all this, so it's more of a reference if needed. But these are just some truly amazing shots. You can see the Earth and the moon there. It was really, really hard for me to pick only 6 pictures to put on this slide. There are so many good ones. Like I could have made a whole slideshow of just all these awesome photos. Maybe I'll do that one day. I don't know. But there's so many good ones. And then these are from their journey home. So one of the things I loved when they did this, so at the same time, of course, we have people in the International Space Station. And so NASA set up a space station to Integrity live call, and they got to talk to each other back and forth. And I thought one of the funniest things they were sitting there comparing food menus. They're like, "Oh, I had the spicy green beans today too." I was like, "People are people. It's kind of just fun." And I love this shot of you can see the Milky Way. Like that's just stunning. If I look, I kind of need that to be my wallpaper. It's so pretty. And of course, here's the crew. They're very close. Once you train together and work together for, so long and then go through something like this, you're very close. And here is splashdown day. So you can see it kind of comes in a little bit like an angle here. That's designed by design. Parachutes help slow it down. Just like before, you see the balloons inflated to help stabilize it. And then we get that nice, as they call the front porch, I believe, around it. And then the U.S. Navy comes and retrieves them. And then they have a big Navy ship, aircraft carrier, I believe it was, nearby. But to get them onto said Navy ship, they picked them up via helicopter one by one. They had 2 helicopters, and they would go and pick up one in a little harness with the safety person, and then they would fly away a little bit while the other helicopter swooped in, got the next person, and then they would switch places, and then they would flew them all back and landed on the deck there of the plane, or not the plane, the ship. Words are hard. And so this is them right after they got back to the ship. You can see they're hanging out here in the I think it's called the hull or something like that, the helicopters. Um, this is their zero G indicator named Rise. I love that the commander decided I'm bringing this with me no matter what. Like he was actually supposed to leave it in the capsule and they get it later, but he's like, no, it's coming with me. I love that. And then afterwards, so this is in the well there of the ship where they kind of grabbed the capsule, tied it down. This is the crew right after taking a nice little photo with integrity. There's their flight path. Again, check that out. Now, this begs the question of how the heck did this all work? So the rocket to get us to the moon is called the Space Launch System, or the SLS. It is again another multi-stage rocket, like I talked about before, and why we need that. It's a super heavy vehicle, which means it carries a lot of fuel and gets a lot of oomph. So its main fuel is that choice of all rocket fuels, liquid hydrogen, which means everything's got to stay super, super cold. Did I write down the temperature? Was I smart enough to do that? No. I'll find it later. So, altogether, this whole rocket, this whole situation, if it's fully loaded, I mean fueled and everything, it is 5.7 million pounds. 5 million of that is just the fuel. It's crazy. So it's got a core stage, two solid rocket boosters, just like with the shuttle, and it's got the capsule and service module there at the top, and it's got the RS-25 engines from the space shuttle. So the core stage, it's aluminum fuel tanks and engines. That is assembled in Louisiana and then transported via barge over 900 miles to Kennedy Space Center. This is where you're going to, that's the big orange section, by the way. Yeah, it's where you're going to see all the liquid hydrogen, liquid oxygen, and it provides a whopping 8.8 million pounds of thrust at liftoff. Like, holy cow. That is quite the roller coaster. Then you also have the SRBs. Those are providing some extra thrust at launch because, again, the goal is not to get into orbit, it's to leave the Earth. So we need extra oomph to get us there. So then we have the RS-25 engines. So these are reused from the shuttle program per Congress. Because again, waste not, want not. Congress is like, you're going to save us any money you can. You're going to reuse what you can. And when they were first developed back in the 70s, they were considered the Ferrari of rocket engines because they were specially designed to work with liquid hydrogen and things like that. Over time, I think people have slowly changed that perspective, but we are reusing them. So the Orion and service module, that is where the crew hangs out for the entirety of the mission. It is good news. It's 50% larger than the Apollo capsule, which is good because Apollo had 3 people, now we have 4. We want some extra leg room. Okay. When this capsule is coming back, it is going Mach 32. So that means it's going 32 times the speed of sound, or about 25,000 miles per hour. That's really fast. This is why the heat shield is so important, because that kind of speed is going to generate a lot of friction. Friction generates a lot of heat. We don't want that. So the heat shield is made of about 1.5 inches of this type of epoxy resin, and the whole reason it does such a good job is it's there to ablate or vaporize, like burn away, as it's re-entering. And that whole process will then deflect the heat from the capsule and therefore not, hopefully, cause problems for the crew inside. I'm very surprised you didn't bark at that. Here's some pictures from the NASA social media of this thing. So this building here is the Vehicle Assembly Building, or the VAB, down in Kennedy. This is the largest single-story building in the world, and this is where we assemble all of the components, hence the name, Vehicle Assembly Building. So you can see from the top up there, kind of the view down. This is a view taken from the bottom. Here's the crawler, the transport again. Here's a person about the size of my mouse pointer. Isn't that bonkers? Here's a infographic from NASA about all the different specs. And then, of course, finally, what are we going to do in the future? Well, obviously, we're going to have a great Artemis program Got to go back to the moon, land on the surface, all that cool stuff. But it's not highly advertised, but basically we're in another space race with China. China has a beast of a military complex and a aeronautical complex, and they are very, very keen on getting to the moon. Not only to one up us because, they want to be and they are a superpower, but also because they're also very interested in all that possible frozen water ice in those craters and things like that. They want those resources too. So we're in another space race. Hooray. I guess time will tell of how that's going to work out. But essentially, that's kind of the most immediate future. Then we're going to focus on hopefully going to Mars in the hopefully not too distant future. I haven't seen a good timeline because, things shift and change. And then I want to focus on settlement versus colony. So if you see a lot of older science fiction, you may hear the term pop up. We're going to establish a colony on Mars, a colony on the moon. We don't use the term colony anymore because it has ties to colonialism. Colonialism, famously not good. Because that's where you just go basically kick down the door of somebody else's country and say, I live here now. This is my country. You deal with it. We're not going to do that because space is for all, as per the Outer Space Treaty and the Artemis Accords, things like that. So we use the term settlement. We're going to settle Mars. We're going to settle the moon. That is a more inclusive term. It doesn't immediately put this negative connotation on it like colony does. So we want to always use the term settlement. And of course, space tourism is a growing industry at the moment, especially with um, SpaceX and Boeing and all them and all their, Virgin Galactic and all them trying to make these different space tourism flights. Time will tell of how successful those are and how much those will be expanded upon. So we'll see. And then, of course, what are your thoughts? What do you think we should do in the future? I'm very curious to know what you want to think about and what you would want to do. So here's some cool infographics just to end out the show. And I'm going to casually find the stop recording button while I continue to talk. And I hope you all have a good day. Bye bye.